Today, we're diving into a really fundamental shift in how we build things for the cloud. And honestly, it's an idea so powerful, it might completely change the way you think about code, about servers, about everything. So yeah, let's get into it. All right, I'm going to start with a pretty bold statement here. For years, we've kind of been sold this idea that writing mountains of configuration files, usually in YAML, is just the price you have to pay for modern cloud development. But what if I told you that all that config, all that YAML, isn't the actual problem? What if it's just a symptom of something much, much deeper? No, really, just take a second and think about that. Imagine, no more fighting with indentation errors. No more digging through docs to remember the exact syntax for some cloud resource. What if your application code was literally all you needed? Just keep that question in the back of your mind as we go. Okay, so to really understand where we're headed, we have to start by looking at where we are. And right now, the way most people work is with something called infrastructure as code. And, well, it's the source of all that YAML we were just talking about. And it's created what I like to call the two-language problem. Now, let's be super clear about something. Infrastructure as code, or IAC, was a massive, massive step up. I mean, tools like Terraform and CloudFormation saved us from the total chaos of manually clicking around in the AWS console, ClickOps. They brought things like version control and automation or infrastructure, and that was an absolute game changer. But for all the good it did, IAC also introduced a new kind of headache. It created this dual-stack reality. Suddenly, you weren't just an app developer anymore. You also had to become an infrastructure expert, whether you wanted to or not. And this slide right here, this shows the problem perfectly. On the left, you've got your app logic, maybe in TypeScript. And on the right, in a totally different language like HCL, is all the infrastructure code needed to make that app logic run. They're both parts of the same feature, but we're forced to write and think about them in two completely separate, disconnected worlds. This constant jumping back and forth, it's just a huge tax on productivity. Every single time a developer has to switch from thinking about application code to thinking about infrastructure definitions, they lose momentum. They lose that incredible state of focus we call flow. And you just know there has to be a better way. And that better way is this new paradigm that's starting to emerge called infrastructure from code. This is where we stop treating the app and the infra as two different things. This is where we start treating them as one. So what is infrastructure from code, or IfC, really? Well, it's a paradigm where the cloud infrastructure you need is automatically figured out. It's inferred, and then it's generated right from your application code. You're not explicitly telling the cloud what to build anymore. Your code is showing it. And this right here, this is the core idea. With IfC, your application code becomes the one and only source of truth. There's no separate Terraform file that can get out of sync or drift over time. What you see in your app's code is exactly what you get in the cloud. Period. Let's make this real with a quick example from a new language called Winglang. I mean, look at this line. It seems so simple, right? It looks like you're just creating a normal object. But that little cloud.bucket part is special. With just that one line, you've declared that your application needs a cloud storage bucket. And this is where the magic happens. When you compile that single line of code, the Wing compiler actually produces two different things. It spits out the application code that's going to run on a server somewhere, and it spits out the infrastructure code, like a Terraform file, that's needed to create that S3 bucket in the first place. This table really just lays it all out. With IAC, the source of truth is a separate config file. With IfC, it's the app code itself. The workflow shrinks from 3 steps down to just 2. But look at these last 2 rows, because this is what really matters. The cognitive load on the developer drops like a rock, and the primary user shifts from being a specialized DevOps engineer to being the application developer. This is all about empowerment. Okay, so this might sound a little bit like magic, right? How on earth can a compiler know how to build a whole cloud environment? Well, let's pull back the curtain and see how it works. Here's a really powerful way to think about it. The compiler is the new cloud. An IfC toolchain is basically a super specialized compiler, but instead of targeting a CPU, its target is the cloud itself. AWS, Google Cloud, Azure, you name it. And it follows the same basic steps as any other compiler. First, it reads your code. Then it builds a logical map of it. That's called an abstract syntax tree. Then it analyzes that map to figure out what you're trying to do. And finally, it generates the output files, both the application and the infrastructure code. But of all those steps, it's number 3, static analysis. That is the absolute secret sauce here. This is where all the really cool innovation is happening. It's the compiler's ability to understand the relationships between different parts of your code and the cloud resources they depend on. And here's a perfect example. Let's say the compiler sees a line in your API code that says queue.push. So it knows you're sending a message to a queue. During static analysis, the compiler figures out, hey, this function needs permission to talk to that specific queue. So what does it do? It automatically generates the perfect, most secure, least privilege IAM policy required. The developer never has to write a single line of that complicated, easy-to-mess-up JSON. That is huge. So we've seen the how, but let's talk about the why. What does this actually mean for developers, for teams? Well, it's something a lot of people are starting to call the Zero-DevOps promise. And what's the first part of that promise? Well, it's about totally changing how teams work. IfC can empower just one single developer to do what used to take a whole dedicated DevOps specialist. By making it so much easier to get started, you just unleash the productivity of every single person on the team. And at the end of the day, by getting rid of that context switching tax we talked about earlier, IfC lets developers stay in that incredible state of deep flow. They can just focus on what they're great at, writing code that solves problems and delivers value, moving fast, without having to worry, because the infrastructure will just materialize around their code. To really get how big of a deal this is, we need to put it into the larger story of software development. Because this is really all about the relentless march of abstraction. You know, when you look at a timeline like this, you realize the entire history of our industry is just about finding better and better ways to hide complexity. We went from machine code to assembly, from C to managed languages like Java. Platforms like Heroku abstracted away the servers, and IAC tools like Terraform abstracted the cloud APIs. Infrastructure from code, it isn't just some random new thing. It feels like the next logical and maybe even the final step in that long journey. Which, of course, brings us to one last pretty provocative thought. We started by asking what it would be like to never write a config file again. But this new world opens up an even bigger question. If our tools get smart enough to compile our code directly into a fully provisioned, secure, scalable cloud application, what does that free us up to build next? What comes after the cloud? It's something to think about. Thanks for watching.